Well, hello, hello. This is the first film, the first short film math documentary lesson from the new house. Yeah, pretty, where's my hands go? Right here. Pretty cool, right? The house. See it? Pretty cool. And I also got a haircut today. Oh, well, pretty cool. Well, math is the same no matter what house I'm in, so don't expect things to be any different. Also, I have a cookie today, and I have a dog. Say hi. Alright, so for lesson 6, I started flipping through the pages. It's intense stuff. The knob for math intensity just got turned up a lot. So it's very important that we understand what's going on here, because this is where people get lost, because you're going to see a lot more letters than numbers, and it's going to be very important that we take it slow to understand these basics so that we can move faster later on. So instead of teaching you 5 different concepts and 5 different lessons, I'm just going to try to teach you everything as simply as possible in one bigger lesson, because math, it all works together anyway. You're going to be using 3 different things in the same problem anyway, so it's just better to learn them all at once to see how they interact instead of learning them all individually. So that's what I'm going to try to do here. We're still talking about polynomials, which is just, just terms being added and subtracted by each other. And remember, a term is just when numbers and letters are being multiplied by one another in one section. But we're going to see how 2 groups of polynomials can be multiplied and divided in this lesson. So buckle up. All right, so to do this, I'm going to build from the ground up how multiplication works. That way we can see how it transitions into polynomials. So if we have 2 numbers, 2 times 3, multiplication is just 2 times 3, we get a 6. Easy enough. Oh my goodness, not easy. What the heck was that? 6. All right. If we have the same number, let's say 3 times 3, we just multiply. One way of writing that is 9, but another way of writing that, we have a special different way. We can say 3 multiplied by itself twice, and we can use an exponent and say 3 squared. So obviously we'd rather write it as 9 because that's what we're used to, but if we needed to, we could write it as 3 multiplied by itself twice. If we had 3 times 3 times 3, then we could just do 3 multiplied by itself 3 times. But yeah, that's just another way of writing a multiplication problem. Another thing we could do is we could have a number times a letter. And when we have that, 2x, we just combine them like this, and we say 2x, and we call 2 the coefficient. Okay? And now we could also have a letter times a letter. So let's say x times y. So there's no way of combining these into one thing, so we'll just write it as xy. So this kind of is similar to what we did up here. There was only really one way of writing it, and so we multiplied them together, and that's what we get right here. Now, we could have the same letter multiplied by itself. We could have x times x, and instead of, it's not 2x, because 2x means there's 2 x's. It's like an addition problem. It's an x plus an x. Here we have x multiplied by itself twice. So we're going to write it the same way we wrote this 3. So we can say x multiplied by itself twice. Okay? All right, let's keep going. Let's say we have a 2x times a 3. Now, remember, this grouping right here, whenever we have two things touching like that, it's just multiplication. So really, this is like 2 times x times 3, okay? And because of our commutative property, we know we can rearrange this. So we could also say 2 times 3 times x. So we know that 2 times 3 equals 6. So we have 6 times x. And then we just know that a number times a variable just gives us this format where we have a coefficient, so 6x. So when we have a coefficient and a variable multiplied by a constant, we really just need to look at the number portions and combine them. So, okay, makes sense? All right, let's take a look at, let's say we have 2x times y. Well, same kind of thing. We can just break it down, realize it's just one big multiplication problem. We know that x times y is xy, and we know that 2 times some variables is just going to equal 2xy. Now, you might think, oh, isn't it 2x, 2y? No, it would be 2x, 2y. It wouldn't be 2x, 2y, because think about it. If we had 2x, 2y, they're all being multiplied by each other, so it's the same as 2 times x times 2 times y, and then just like we had up here, we would combine the number portions, so that would give us 4xy. So don't get confused there. When we're dealing with just one term, remember, the things being multiplied together are just one term. You just really need to treat this as a coefficient and tack it in front of our variable portion. Now let's take a look at this. Let's say we have 2x times x. Well, let's just treat it like we've been treating it. Recognize that it's all one big multiplication problem. We know what x times x is. X multiplied by itself twice is going to give us x squared. And then just like all the other times, a constant portion multiplied by a variable portion just means we tack the 2 on in front of the variable portion. Okay? And then let's take a look at one more scenario. Let's say we have, well, let's take a look at 2 more scenarios. Let's say we have 2x times 3y. Well, let's just, really, when you get to these multiplication problems, just break it down into numerical portions and variable portions. So it's like combining like terms in a way. So numerical portions, we got 2 times 3, that's going to give us 6. And then the variable portions, we got x times y, which gives us xy, and then we can just combine it just like all the other times when a constant and two variables come together. And then I think there's room for one more. We can say 2x times 3x. Combine the numerical portions, that gives us 6. Combine the variable portions, x multiplied by itself twice, that's x squared. They combine to get 6x squared. So, if you have any questions about, I think I covered all the different types of multiplications we could have. So just if you need to take a screenshot or write all these different combinations down. Here we have a constant times a constant. Here we have the same constant multiplied by itself. Here we have a constant times a variable times a variable, and the same variable times itself. Here we have a coefficient in a variable multiplied by a constant, coefficient and variable multiplied by a variable, coefficient and variable multiplied by the same variable, coefficient and variable multiplied a different coefficient and different variable, and the last one, two coefficients and the same variable. So I think these are pretty much the only types of multiplication we can have. So just make sure if you have any questions about it, you got to write it down so that you can ask me during car math or whenever we have our time together. So knowing these multiplications are pretty much all you're going to need for the rest of lesson 6. Now let's take a look at, so what we were working with previously were monomials. Remember, monomial is just one set being multiplied by another, well, one term being multiplied by another term. A polynomial is when we have a few terms together. For example, 2x plus 3, or we can have 6 plus y plus x plus 3xy, that's 4 terms in the polynomial, and then anything in between. But the thing, just remember, it's pluses and minuses that separate the terms, and however many different terms we have, that determines the length of the polynomial. So let's say we have two polynomials, or let's just take a monomial times a binomial. Binomial just means there's two of them. Okay, so monomial versus a binomial, let's just say, for simplicity, 3 plus y. So here we have one term being multiplied by a polynomial. Okay, so how do we do this? Well, first of all, you might recognize that we have distribution going because we have something on the outside being multiplied through parentheses. So you know how distribution works. That just means we multiply 2x times 3 and 2x times positive y. And based on everything we just broke down, you know how to do each of those separately. So what's 2x times 3? That's just going to equal 6x. And what's 2x plus 2x times positive y? That's going to be 2xy. So this, when we multiply this monomial times this binomial, we get this binomial. And it's using things we already know. We already know how to multiply these two things together. We already know how to distribute. So it's nothing new. Nothing new. Okay, let's take a look at another example. Let's say we have this one here. We have this monomial times this binomial. So once again, it's just distribution. So we got 3y times 4, that's just going to equal 12y. And then we have 3y times positive y, that's going to be 3. And then y is multiplied by itself twice, so 3y squared. That's all there is to it. So when we multiply this monomial times this binomial, we get this binomial. Okay, let's take a look at another example. Actually, I want to take a break to just review. Actually, I'm going to make a separate video for reviewing exponents. We'll just carry on from here. Actually, I think I made an exponent video. I'll double check, but if not, I'll make one. All right, so now in this example, we have a monomial multiplied by a trinomial. So it might be a little bit intimidating, but it's just the same. It's just distribution. Distribution just multiplies everything, the outside thing, by everything on the inside. So we know how to do these multiplications separately, so let's do them. 4x times 2 is going to give us 8x. 4x times negative x is going to give us negative 4. X is multiplied by itself twice. And then lastly, we have 4x times 3y. That's going to give us 12xy. All there is to it. It's just a distribution problem. That's nothing crazy, just distribution. All right, here we got a monomial times a monomial. Well, let's just think of it like combining like terms. Let's look at the numerical parts. 3 times 4 is 12. Let's look at the x's. X is multiplied by itself twice, and then y, it's just itself because there's nothing to multiply it by. Let's take a look at something more complicated. Let's say we got 3y times 4xy times 6 y squared. Okay, so let's just do the numbers first. 3 times 4 times 6 is going to give us something. I'm going to say it is 72. How many y's do we got? We got y multiplied by itself once, twice, and 3 and 4 times. So remember, this is y multiplied by itself twice, times a third time, times a fourth time. So we can just write that as y to the power of 4. And then we got an x all by itself. Nothing complicated. We're really just we're combining like terms through multiplication. You've combined like terms before with addition and subtraction. This is a similar type of thing through multiplication. Now, there is one more. We know how to distribute through. We know how to multiply monomials together. Now, there's one more special case that it's a type of distribution. You've just never seen it before. Here we have a multi-term polynomial times another multi-term polynomial. Before we were only multiplying by a monomial on the outside. So let's see what happens here. So just like distribution, this term is going to get multiplied by everything on the inside once. But since there's two terms in this parenthesis, we're actually going to do that for each of the terms. So x is going to get distributed to each of them once, and positive 2 is going to get distributed through each of them once. So this is how we're doing it. It's called foiling, and I'll tell you why. So the first thing we multiply, well, it's better if I move it down. All right, foiling. So FOIL stands for first, outer, inner, last. First, outer, inner, last. And what that means is we're going to multiply the first terms together first. So see how x is the first one in each of them. So we're going to do x times x, which is x multiplied by itself twice, which is x squared. Then we're going to do the outside terms, which is, look at the whole group. X is on the outside here, and 3 is on the outside. We're talking like the outside of what we're looking at. So x times negative 3 is negative 3x. And then we're going to do the inner, and that's just these guys right here. So positive 2 times x is going to give us a positive 2x. And then lastly, we have positive 2 times, and then L stands for last. So we're going to multiply the last terms together. So we're going to multiply positive 2 times negative 3, which gives us a negative 6. And so we've just turned this monomial times this monomial into a quadnomial. But if we want to reduce, look, we can combine like terms right here because we have the same variables with the same exponents. So we're going to do that. We can't simplify x squared. Negative 3x plus 2x is a negative x, and then we have a negative 6. So this is called foiling. And this comes into play whenever we have two binomials being multiplied by each other. So I'll do one more example. All right, we have a binomial multiplied by another binomial. So we're going to do FOIL. FOIL comes into play whenever we have two binomials being multiplied by each other. So we'll take a look at the first ones first. That's that 5 and that 1. So we're going to get 5 times 1, which is 5. Then we're going to do the outers, which is the 5 and the y. 5 times y is 5y. And we're going to do the inners. We've got negative 3y times 1, which is negative 3y. And then we have the last, which is going to be the negative 3y times the y, which is just going to be negative 3 and then y multiplied by itself twice. And then from there, we just need to combine like terms. So we've got 5. And then we got 5y minus 3y, which is just 2y. And then we've got negative 3y squared. And then it's best practice to order it based on the exponent. So we're going to order it as negative 3y squared plus 2y plus 5. So this lesson is pretty much just an overview, starting from our basic multiplications, and that's what this lesson is built on. This whole lesson 6 is built on. It's based on the multiplication. So as soon as we know how to do the multiplications, then it's just a matter of distributing the proper way. If you have questions, you need to write them down and ask me. This was an overview. It wasn't meant to, you know what an overview is. I don't need to explain it, but just write down your questions so that you're clear as you can be. And then I'll see you when I see you. Bye. Oh, bye. How do I end it? Bye.